Hello students, we are going to discuss test 23 today. The topic was wave optics. In the first question, it is given that the displacement of two interfering light waves are given by y1 is equals to 4 sine of omega t and y2 is equals to 3 cos of omega t. We want to find the amplitude of resultant wave. Here, to find the amplitude of resultant wave, we will use the phasor method. The angle between y1 and y2 is 90 degree. So resultant will be under root 3 square plus 4 square, that is equals to 5 centimeter. So option 1 is correct option. In question number 2, two coherent sources of different intensities and waves that interfere. The ratio of maximum to minimum intensity is 25. That is, I max divided by I minimum is given 25. We want to find the intensity ratio of the sources. That is, we want to find I1 is to I2. Here I max divided by I minimum is given as under root I1 plus root I2 divided by root I1 minus root I2 whole square, and this is given 25 is to 1. So taking square root on both the side, we can write root I1 plus root I2 divided by root I1 minus root I2 is equals to 5 is to 1. Now use componendo and dividendo. We will get root I1 plus root I2 plus root I1 minus root I2 divided by root I1 plus root I2 minus root I1 plus root I2 is equals to 5 plus 1 divided by 5 minus 1. So root I1, this will get cancelled out, divided by root I2 is equals to 3 by 2. So I1 by I2, squaring both the side, we will get I1 by I2 is equals to 9 is to 4. So option 3 is correct option. In question number 3, it is given that two sources of intensity 2I and 8I are used in an interference experiment. The intensity at a point where the waves from two sources superimpose with a phase difference of first is 0, second is pi by 2 and third is pi. For this three different interference angle, we want to find the intensity of interference. The intensity of interference is given by I1 plus I2 plus 2 root I1 I2 cos theta. So I effective will be 2I plus 8I plus 2. 8 2s are 16, square root of 16 will be 4, so that will be 4I into cos 0 will be 1. So this will give us the answer 8 effective is equals to 18I. Now putting theta 2 is equals to 90, this term will be 0, so I effective will be simply 2I plus 8I, that is equals to 10I. Now keeping theta is equals to pi, in this equation we will get I effective is equals to 2i plus 8i minus 8i. So this will give us the answer 2i. So the answer will be 18i, 10i and 2i. So option 1 is correct option. In question number 4, the intensity of interference waves in an interference pattern is same as I naught. We want to find the resultant intensity at the point of observation. Here, let's say A1 and A2 are the amplitudes of resultant amplitude A. So resultant amplitude is given by A1 square plus A2 square plus 2A1 A2 cos phi. It is given that A1 and A2 are same. So A1 is equals to A2 is equals to, let's say, A naught. So A square will be equal to 2A naught square plus 2A naught square cos phi. Taking 2A naught square common, so A square is equals to 2A naught square 1 plus cos phi. So intensity A square is equal to intensity is equals to 2 I naught into 1 plus cos phi. So option 1 is correct option. In question number 5, in Young's double slit experiment, the constant phase difference between two sources phi is given pi by 2. We want to find the intensity at a point equidistant from the slit. Here, as slit is equidistant, then the intensity will be given by I naught by 2 into 1 plus cos phi. Here phi is pi by 2, so I will be equal to I naught by 2 into 1 plus cos pi by 2. But cos pi by 2 is 0, so I will be equal to I naught by 2. So option 2 is correct option. In question number 6, the path difference between two interfering waves at a point on the screen is lambda by 6. That is delta x is equals to lambda by 6 from central maximum. We want to find the ratio of intensity at this point and that at the central fringe. Here the phase difference or path difference is given lambda by x. We know that intensity is given by I naught into cos square phi by 2. So I divided by I naught will be equal to cos square phi by 2. The phase difference phi is given by 2 pi by lambda into delta x, that is 2 pi by lambda into lambda by 6, that is equal to pi by 3. So I divided by I naught is equals to cos square pi by 3. Cos pi by 3 is root 3 by 2. That is equal to 3 by 4. So I divided by I naught is equals to 0.75. So option 1 is correct option. In question number 7, in Young's double slit experiment, 12 fringes are observed to be formed in a certain region of the screen when light of wavelength 600 nanometer is used. That is N1 is equals to 12 fringes. Now, if the wavelength of light used is 400 nanometer, then what will be the number of fringes observed in that region? Here, wavelength of light used is inversely proportional to the number of fringes observed. So we can write N1 lambda 1 is equals to N2 lambda 2. So N2 will be equal to N1 lambda 1 by lambda 2. So N2 is equals to N1 is 12, lambda 1 is 600 divided by 400. So N2 will be 18. So option 2 is correct option. In question number 8, a double slit apparatus is immersed in a liquid of refractive index 1.33. It has slit separation 1 mm and distance between the plane of slits and screen, that is capital D, is equals to 1.33 meter. The slits are illuminated by a parallel beam of light whose wavelength is 6300 angstrom. We want to find the fringe width. The fringe width beta is given by lambda d by d. So beta will be lambda is 63 into 10 power minus 8. D is 1.33 meter, but here the lambda is given in air, so lambda in this medium will be lambda dash, that is equals to lambda by mu. So that will be equal to divide by 1.33 into small d is 1 millimeter, that is 10 power minus 3. So fringe width will be, simplify this, we will get 0.63 mm. So option 4 is correct option. In question number 9, the fringe width at a distance of, it is D is equals to 50 centimeter from the slit in Young's experiment for a light of wavelength 6000 angstrom is 0.048 centimeter. The fringe width at the same distance for lambda is equals to 5000 angstrom will be. So we want to find beta 2. The fringe width is given by lambda d by d. Here d is same in the experiment. It is given in the question that capital D is also same. So we can write B is directly proportional to lambda. So B1 by B2 is equals to lambda 1 by lambda 2. So B2 will be equal to B1 lambda 2 by lambda 1. So B2 will be equal to B1 is 0.048 into lambda 2 is 5000 angstrom divided by 6000 angstrom. Simplify this, we will get B2 is equals to 0.04 centimeter. So option 1 is correct option. In question number 10, in Young's double slit experiment, the two slits are illuminated by the light of wavelength 5890 angstrom and the distance between the fringes obtained on the screen is 0.2 degree. If the whole apparatus is immersed in water, then the angular fringe width will be we want to find the angular fringe width. In the case it is immersed in a liquid of refractive index 4/3. Here, for interference in Young's double slit experiment, d sine theta is equals to n lambda. But for small value of theta, we can write theta is equals to n lambda. Now, as the setup is immersed in water, lambda dash will be equal to lambda by mu. That is equals to lambda divided by 4/3. That is equals to 3 lambda by 4. So, lambda 1 by lambda 2 is equals to theta 1 by theta 2. So, theta 2 will be equal to theta 1 into lambda 2 divided by lambda 1. Theta 1 is given 0.2 degree. Lambda 2, that is 3 lambda dash, that is 3 lambda 1 by 4 divided by lambda 1. This lambda 1 will get cancelled out. So, theta 2 will be 3.3 divided by 2, that is equal to 0.15 degree. So when it is immersed in liquid of refractive index 4/3, the angular fringe width will be 0.15 degree. So option 2 is correct option. In question number 11, a plate of thickness T made of material of refractive index mu is placed in front of one of the slit and double slit experiment. We want to find the minimum thickness T, which will make the intensity at the center of the fringe pattern 0. Here, to have intensity of fringe pattern at center 0, the path difference should be mu minus 1 into T. It should be equal to n plus 1 by 2 into lambda by 2. And we want minimum thickness, so n should be 0. So mu minus 1 into T, it should be equal to lambda by 4. So T will be equal to lambda divided by. In question number 11, a plate of thickness T made of material of refractive index mu is placed in front of one of the slit in double slit experiment. We want to find the minimum thickness T, which will make the intensity at the center of a fringe pattern 0. Here, the path difference created by this slit will be mu minus 1 into T, and that should be equal to 2n minus 1 lambda by 2. To have the minimum thickness, n should be equal to 0. So, mu minus 1 into T is equals to lambda by 2. So, T is equals to mu divided by 2 into, this is lambda divided by 2 into mu minus 1. So, option 3 is correct option. In question number 12, the maximum number of possible interference maxima for slit separation equal to twice the wavelength, that is D is equals to 2 lambda. For this case, how many maximum number of interference maxima can be observed? Here, for maxima, the condition is d sine theta is equals to n lambda, but it is given d is equals to 2 lambda. So 2 lambda sine theta is equals to n lambda. So 2 sine theta will be equal to n, and sine theta will be equal to n by 2. We know that sine theta is less than or equal to 1, so n by 2 will be less than or equal to 1. So n is less than or equal to 2. So n max is equals to 2. That is n is equals to 0, 1 and 2. For this 3 value of n, we will get n is equals to 0, plus or minus 1 and plus or minus 2. So maximum number of possible maxima will be total 5. So option 2 is correct option. In question number 13, two identical coherent sources produce a zero order bright on the screen. If B is the bandwidth, the minimum distance between 2 points on either side of the bright fringe where the intensity is half of the maximum intensities, that is I is equals to I by 2. If this is the screen, this is central point, at this point maximum intensity will be I naught. So we want to find the distance between 2 points where the intensity is I naught by 2. Here we know that I at any point is given by I naught cos square theta by 2. It is given that IP is I naught by 2. So I naught by 2 is equals to I naught cos square theta by 2. So cos square theta by 2 is equals to 1 by 2. So cos theta by 2, that is equals to 1 by root 2, given theta by 2 is equals to pi by 4. So theta is equals to pi by 2. Now theta is equals to pi by 2 is equals to 2 pi by lambda into delta x. From this we can write delta x, that is path difference, is equals to lambda by 4. Now delta x is equals to n lambda. So lambda by 4 is equals to n lambda. So n is equals to 1 by 4. Now we want to find distance yn is equals to n lambda d by small d, that is equals to 1 by 4, but lambda d by small d is the fringe width, that is beta. So yn will be equal to b by 4. So option 2 is correct option. In question number 14, two statements are given. We have to check whether they are true or not. The first statement says that in the interference pattern, the intensity is same at all points in a bright band. Let us check about that. The intensity at any point is given by 4 I naught cos square theta by 2 for any bright point and all points. Theta is constant. For any bright band at any point, theta is constant. So IP is constant. So first statement is correct. Now the second statement. In Young's double slit experiment, as we move away from the central maximum, the third maximum always comes before the third minimum. here we will check about that. Yn is equals to 3 lambda d by d, and yn is equals to 2n minus 1 lambda d by d. Put n is equals to 3 here, so y3 will be equal to 5 lambda d by d. So this is the maximum and this is the minimum position. The maximum position is less than minimum position, so maximum appears before third minimum. So both statements are correct. So option 1 is correct option. In question number 15, first diffraction minima due to a single slit diffraction is at theta is equals to 30 degree for a light of wavelength 6000 angstrom. We want to find the width of the slit. In single slit experiment, A sin theta is equals to m lambda, where A is the slit width. For first width, m is equals to 1. So we can write A is equals to lambda divided by sin theta. Lambda is given 6 into 10 power minus 7 divided by sin theta, that is sin 30 degree. So A is equals to 12 into 10 power minus 7. So A is equals to 1.2 into 10 power minus 6 meter. So option 2 is correct option.